So you learned in class today that work is done when you apply a force through a distance. If there's no distance, there's no work. In this particular picture, the person is applying a force in the same direction as the displacement of the car. But that's not always the case. So to correct for that, the actual equation that we're going to use for work is work equals force times distance times the cosine of the angle between the force and the distance. That's why this cosine is between force and distance. So in this particular example, there's a woman applying a force to a suitcase. One of these suitcases on wheels. And the suitcase is traveling through a distance, but the force that she's applying isn't in this direction. The force she's applying is at an angle. So the work done by a 45 Newton force pulling on this suitcase at an angle of 50 degrees for a distance of 75 meters. We're going to apply the equation that we saw on the last slide, that work equals force times distance times the cosine of the angle. So here's the solution to the problem with the numbers all plugged in for you, where we have work equals force times distance times the cosine of the angle. Our force was 45 newtons, our distance was 75 meters, and our angle was 50 degrees. So 45 times 75 times the cosine of 50 gives us a work of 2,170 joules. So don't forget that the unit for work is in joules. Here we have another example where we have a person that's lifting weights. Over here they're lifting the weight up, so they're applying a force upward, and the displacement is up. In the second diagram, they still have to push up, otherwise the weight would fall on them, but they can push up while lowering the weight down. So in this example, the weightlifter is bench pressing a barbell whose weight is 710 newtons, and he raises the barbell a distance of 0.65 meters above his chest. And the second picture, it's the same weight and it's the same distance, but the direction is a little bit different. So when our weightlifter was lifting the weight up, they applied a force of 710 newtons, a distance of 0.65 meters, and the angle between the force and the displacement was 0. And we love it when the angle is 0 because the cosine of 0 is just 1. So 710 times 0.65 tells us that the weightlifter did 460 joules of work on the barbells. And when the weightlifter was lowering the weights, they were still applying a force of 710 newtons through a distance of 0.65 meters. But now the angle between the force and the displacement was 180 degrees, and the cosine of 180 degrees is -1. So now our work is negative 460 joules. Here in this next example, we have a crate sitting on the back of a flatbed truck, and the truck is accelerating down the road with an acceleration of 1.5 meters per second squared. Now, if the crate doesn't slip off of the back of the truck, it means that there's a frictional force between the crate and the bed of the truck that's being applied to the crate so that the crate moves with the same acceleration. So if we want to look at this displacement of 65 meters undergoing an acceleration of 1.5 meters per second squared, what's the total work done on the crate by all of the forces acting on it? let's briefly take a look at the normal force and the crate's weight. Both of these have an angle of 90 degrees with the displacement. And if we apply our equation, work equals force times distance times the cosine of the angle, the cosine of 90 degrees is just 0. So the normal force isn't doing any work, and the weight also isn't doing any work. So the only force that's doing work on the crate is friction. So now we're going to take a look at the work done by friction. So the frictional force is equal to mass times acceleration. So if the crate has a mass of 120 kilograms and an acceleration of 1.5 meters per second, then the force applied to the crate is 180 newtons. And if that force is being applied through a distance of 65 meters, the angle between the frictional force and the displacement is 0. So we simply have 180 newtons times 65 meters times 1 is equal to 1.2 times 10 to the 4th joules, or 12,000 joules of work. And we'll take a look at more examples of work tomorrow in class.